Hey YouTubers, welcome back to this channel. It's going to be a little quick video based on a crank no start condition on this 2016 Dodge Challenger with a 3.6 liter engine. This vehicle's already diagnosed, but I'm just going to show you guys real quick what to look for to determine a faulty fuel pump. So pretty much the first step I took was to determine the customer's complaint was to do a crank, and the vehicle was a crank no start. So then I hooked up my scan tool and I looked at the RPM, the cam sync, the crank sync, and the crank missing signal to see if we were missing any of those inputs. So I'm going to show you guys real quick. Alright guys, so this is the scan tool already hooked up. This is with the key on engine off at the moment. I got the SD relay desired state, shows false. Cam sync state shows out of sync. Crank signal missing shows false. Crank signal state shows out of sync. Engine speed 0, fuel level percent 5%. Fuel pump relay desired state shows false. So before I crank the engine, I'm gonna go ahead and turn the ignition off real quick, and then turn it back on into key on engine off. But I want you guys to focus on the ASD relay state and the fuel pump relay state. These two pits should go from false to true for about 2 seconds as the fuel pump primes. So here we go. And that's pretty much going to confirm that the computer is receiving those signals. So here we go. I'm going to turn it off. Back on. So here you go. True. About for 2-3 seconds, and then they went back to false. So at least those two pits are working as desired. So now the next step I'm going to do is to crank the engine. And let's concentrate on the cam sync state, the crank sync state, and these two pits should go from out of sync to sync. The crank signal missing pit should stay false, and if it goes to true, then that means that we are missing the crank signal. So here we go. So like I said, cam sync and the crank sync should go to true as I crank the engine. So here we go. The engine might crank a little bit odd due to the fact that the battery's a bit low. So here we go. So right now, as you see, is in sync on both of them and false on the missing signal. So that was good. All right guys, so the next step I'm going to do is go back into the engine bay, spray some starting fluid into the throttle body, and the vehicle should crank over momentarily and then turn off again. And that pretty much confirms that our fuel pump might be the suspect culprit, but in this case, since I already diagnosed it, our problem is the fuel pump. It's no longer priming. All right, yeah, so I'm gonna go ahead and start use the starting fluid. I'm gonna place some into the throttle body, not too much, just enough. So here we go. I'm gonna go into the engine and crank the engine real quick. And the vehicle should turn on momentarily. So here we go. We're missing a little bit more starting fluid. A little bit of backfire with the starting fluid. That's why, like I said, just be careful on how much you guys put into the throttle body. But as you guys saw, the vehicle did turn on momentarily. Alright, so the next step I'm going to show you guys is the voltage checks at the relay box. which is at the trunk. Alright guys, so before I show you guys the voltage checks at the relay box, which lives right there, this is the relay for the fuel pump. I'm going to go ahead and actuate the fuel pump relay, and let's concentrate on the fuel pump relay desired state. I'm going to hit toggle, and the fuel relay should click as I toggle the relay. So here we go. So right now it's toggling. True, false, and the relay is clicking. Like I said, it's this one right here. That's your relay for your pump. So that so far shows good, but it's not 100% sure that the relay is working 100% without doing your voltage checks. So here we go. Alright YouTubers, I'm going to go ahead and use my Kelvin tool. This is a relay bypass unit, which replaces the fuel pump relay. And with this little unit here, I'm able to activate the fuel pump manually. And at the same time, this is like a breaker box too, where where I'm able to actually check the voltages and grounds for each pin. For example, pin 30, 86, 85, 85 and 86 are your control circuit. Your 30 and 87 is your load circuit. As the relay gets energized from 85 and 86, the contacts from 30 to 87 should close and prime the fuel pump. And like I said, it's connected to the location where the fuel pump relay lives. Alright, so guys, so right now, just with the key on engine off, it's showing that pin 30 on the relay showing a battery voltage, which comes from that 30 amp fuse, which lives right here. I'm gonna go ahead and test it with the test light. The test light should turn on, so that shows us that this is a solid battery voltage from the fuse. I'm gonna go ahead and test it with the voltmeter. Should be approximately 12 volts, 12.24. Like I said, this battery is a bit low due to my previous diagnosis where I was cranking the engine, so it brought the voltage down a bit. So the next thing I'm going to do, check the ground on pin 86. It should be less than 0.1, which it is. It shows 0.013, 13 millivolts. I'm going to use a test light connected to battery positive. The test light should turn on real quick. There we go. So now I'm going to use a voltmeter, check on pin 85, which is our control wire. So this is the control wire that comes from the computer. This is a power side switch. So currently it's showing 5.92. So is this a problem? Alright guys, so for some power side switch fuel pump circuits, there's some but not all vehicle manufacturers provide a bias voltage. This is actually a bias voltage that the computer is providing to the to the relay, and is there to pretty much it's for the diagnostic purposes to determine if there's some type of electrical problem on the fuel pump circuit on the control side. But if I use a test light connected to ground, this voltage should actually drop to 0 since alright, so here we go. As you can see, it dropped to 0.1. That's pretty close to 0. If I let go again, it goes back to the bias voltage. But the most important thing, guys, is if the test light turns on, that's pretty much telling you that there's some type of short to ground on the circuit. In this case, as I put it into the socket there, our light is turned off, which is good. There's no problem with the relay circuit on the control side. And as I remove the test light, you see that the 85 goes back to with that little red indicator. If I touch it, it goes out, so that's good. So like I said, this is a bias voltage, so don't get alarmed or get confused that the computer is actually priming the fuel pump at all times, which is not. Like I said, this is just a bias voltage. It's for diagnostic purposes for the computer to determine if there's a problem with the control circuit. All right, guys. So the next step I'm gonna do for you guys, I'm gonna go ahead, put my voltmeter into socket 87. So currently it's showing 0. As I close the contacts between 30 and 87, this 87 should go from 0 to 12. So here we go. I'm going to manually close the contacts with the tester here. I'm going to hit it down. So here we go. It shows 12.24. So that means that the relay is closing, and it is sending the 12 volts to the fuel pump, and the fuel pump should prime. I'm going to turn it off. It should go back to 0, which is good. Now I'm going to go ahead and connect the test light, and this test light should turn on as I hit the switch again. So here we go. That's good. And the last thing, I'm going to go, do for you guys, I'm going to use the scan tool and actuate the relay. And this pin 85 should go on and off. So let me set up and show you guys. Okay, so with the scan tool actuating the fuel pump relay, I have it on the toggle. And let's look at the breaker box here. As the engine's controlling the fuel pump relay, we see that our indicators are going from green to red. Our voltage is going from bias voltage to 12. Remember, on the power side switch circuit with the fuel pump activated, our 86 pin should read 0. Our pin 85, as the computer controls the pump or primes it, should read 12 volts. So with the key on, engine off, the power side switch should read 0. Pretty much 0 and 0. And as the computer activates it, it should read 0 volts on 86, and then 85 should read 12 volts as indicated here on the multimeter. It goes from bias voltage to 11, close to battery voltage. Alright, so I'm going to turn it off. As I turn the actuation off, we go back to the bias voltage, which is 5.9. It should be just above 6 volts, I think about 6.2, since the battery is a bit low. So pretty much, that's our, those are the voltage or the test to perform at the relay. If everything checks out properly with the voltages, then pretty much your problem is your fuel pump. The last step I'm going to do for you guys, go to the fuel unit and show you guys that the fuel pump is receiving the power to pin 87 as I prime the engine with the key on, engine off. So let me set up. So I'm here at the left side of the rear seat. This is where the main unit fuel pump lives. So I'm pretty much going to check the power and ground. I'm currently back probing the ground wire, which is the black wire, which is pin number 4. I'm going to show you guys real quick. This is a little diagram here that comes with the new fuel pump. So the original setup shows here that pin number 5 is your fuel pump positive, your pin number 4 is fuel pump negative, pin number 3, it's your fuel level sensor left side signal, number 2 is fuel level sensor ground, and number 1 is fuel level sensor right side signal. So like I said, I'm currently back probing pin number 4, which is our ground. Our test light is connected to battery positive. Test light is lit, which is a good ground on for the fuel pump module. I'm gonna go ahead and switch the test light, connected to battery negative. I'm gonna go ahead and connect back probe pin number 5, which is the blue with orange stripe wire. So currently with the Kion engine on, the test light is off. I'm gonna turn the ignition off and back on, and this test light should turn on for about 2-3 seconds and then turn off, which tells us that the fuel pump is being primed. So here we go. Ignition off, back on, test light's on for 2-3 seconds, then back off. So that just verifies that the fuel pump is receiving the power and ground. But as you saw, that the fuel pump is not priming. There's no noise on the fuel pump motor. It's dead as, is pretty much dead. It's not priming, it's not making any noise. I'm gonna go ahead and try to see if I could ohm pin number 4 and 5 and see, you know, what it gives us. All right, so I'm currently ohming out pin 4 and 5 on the fuel module pump. It's currently showing 217.2 ohms. The specs for this, which I'm gonna show you guys a picture with the brand new fuel pump. It should be about 0.4. And there's actually no continuity between pin and 4. As you can see, there's no buzzing sound. Alright guys, so this is the final clip here with the fix. I've already replaced the fuel pump. I'm going to show you guys the brand and the part number on the top left corner. Alright guys, so I'm going to go ahead and put the Kion engine off, and we should hear the fuel pump prime for 2-3 seconds. So here we go. Alright, so the next step is to crank the engine, and the vehicle should should crank over. So here we go. So that's pretty much the fix, guys. New fuel pump. I'm gonna go ahead and rev the engine. Alright guys, so this is Eli the OBD Tech. Subscribe if you like.